Hello everyone, my name is Han Shengxiang. This is the question 2 in homework 2 of the course Probability and Statistic process. In this question, there is a sound signal x1 to be transmitted through a noisy channel and get the received signal x2, and x2 will transmit it to the next noisy channel and so on. And for the sound signal x1, the probability of x1 equals 0 is equal to 0.2, and the probability of the signal x1 equals 1 is equal to 0.8. And in this question, for all k, the later receive signal have some condition depends on the sound signal, and the probability of the xk plus 1 equals 0 on the condition of xk equals 0 is equal to 0.6. And the probability of xk plus 1 equals 1 in the condition of xk equals 0 is equals to 0.4, and the probability of xk plus 1 equals 0 in condition of xk equal 1 is equals to 0.3, and the probability of xk plus 1 equals 1 in condition of xk equals 1 is equals to 0.7. So we can get the probability of the matrix of probability x k plus 1 equals 0, and the probability of k plus 1 equals 1 is equal to the probability of xk plus 1 equals 0, xk equals 0 times the probability of xk equals 0 plus the probability xk plus 1 equals 0 in conditional of xk equals 1 times the probability of xk equals 1, and the probability of xk plus 1 times equals 1 is equals to the probability of xk plus 1 equals 1 in conditional xk equals 0 times the probability of xk equals 0, and plus the probability of xk plus 1 equals 1 in condition of xk equals 1 times the probability of xk equals 1. So it can be write as equals to the probability of xk equals 0, the matrix probability of xk equals 0 and the probability of xk equals 1 times the matrix of the behind condition. We can write it the probability of xk plus 1 equals 0 in conditional xk equals 0, and the probability xk plus 1 equals 0 equals 1 conditional of xk equals 0, and the conditional of the probability of xk plus 1 equals 1 in the conditional xk equals 0, and the probability of xk plus 1 equals 1, and conditional in the condition of xk equals 1 is in this two matrix multiple, so we can write it as this probability. So it equals to the matrix probability of xk equals 1 and the probability of xk equals 0 times the matrix 0 0.6, 0 0.4, 0 0.3, and 0 0.7. So we can set this matrix equals the matrix A. So for question 1, if we want to find the probability of x2 equals 1, we can compute the by this matrix sk x2 probability of x2 equals 0 and the probability of x2 equals 1. This matrix is equals to the probability of xk minus 1, x1 equals to 0, and the probability of x1 equals 1, and times the matrix A. So, and the probability of x1 equals 0 is 0.2, and the probability of x equals 1 is 0.8, and the multiple by the matrix A is 0.6, 0.4, 0.3, and 0.7. So the result is 0.36 and the 0.64 or 64. So the probability of x2 equals 1 is 0.64. And for the second for the question 2, and we want to find the probability of x3 equals 1, is we can use the same method, and we could compute the matrix of probability x3 equals 0 and the probability of x3 equals 1 is equals to the matrix of probability of x2 equals 0 and the probability of x2 equals 1 times the matrix A, and is equals to the probability of x1 equals 0 and the probability of x1 equals 1. This matrix to times A and times A. So we could compute it, use the question condition is equals to the 0.2 and the 0.8 to multiply by the matrix in before is equals to 0, 6, 0.6, 0.4, 0.7, 0.3, 0.7, and multiply by 0.6, 0.4, 0.3, 0.7. Also is equals to the equals to the 0.408 and 0.592. So we can find the probability of x3 equals 1 is equals to the 0.592. For the third question, we want to find the probability of x equals 0 in condition x3 equals 1. So in this probability, we could use the function of conditional probability, and it's equals to the probability of x1 equals 0 and x3 equals 1 over the probability of x3 equals 1. So for this probability, we could split it to the two probability plus together. So it's equals to the probability of x1 equals 0 and x2 equals 0 and x3 equals 1, because X signal transmitted to the X2 signal, and X2 signal transmitted to the X3 signal. So the X2 signal can be two conditions, so it can be plus by these two probability, x1 equals 0, x2 equals 1, and x3 equals 1 to over the probability of x3 equals 1. So in these two probability, we could compute it as one, the probability of x1 equals 0, x2 equals 0, and x3 equals 1 is equals to the probability of x1, x3 equals 1 in conditional of x2 equals 0 and the x1 equals 1 times the probability of x2 equals 0 and x1 equals 0, and is equals to the probability of x3 equals 1 in condition of x2 equals 0 and x1 equals 0 times the probability of x2 equals 0 in condition of x1 equals 0 and times the probability of x1 equals 0. So we can use it three probability to times together. So we could also use the conditional in the question for this and this four condition. So in this question the probability of x1 equals 0 and x2 equals 0 and x3 equals 1 is equals to the 0.2 times 0.4 times 0.7 and plus the probability of x1 equals 0, x2 equals 1, x3 equals 1 is 0.2 times 0.6 times 0.4, and we could use the above questions result. The probability of x3 is equals 1 is 0.592 to over the 0.592 is equals to the about 0.1757. And for the fourth question, we want to find the limit when the n is the infinite and we want to find the probability of xn equals 0. In the above questions, we could find that the probability of xn equals 0 and the probability of xn equals 1 matrix could be the probability of x1 equals 0 and probability of x1 equals 1, the matrix times the a to the power of n, and we want to compute the matrix a power to the power of n, and we must put the a into the diagonalization is equals to put the matrix A P matrix times A times the P inverse P matrix is equals to the diagonalization matrix, and we want to we should find the eigenvalue and the eigenvector of the A matrix, and we could get the the P matrix. So we want to compute the eigenvalue. So the eigenvalue can be compute the lambda E minus A is equals to lambda e lambda minus 0.4 0.6 and minus 0.4, the minus 0.3 and the lambda minus 0.7, and is equals to the lambda minus 0.3 more times the lambda minus 0.7 and minus the 0.4 times 0.3, and this is equals to 0. So we could get the eigenvalue lambda 1 is equals to 1 and lambda 2 is equals to 0.3. So we could compute the P by compute the eigenvector. The eigenvector when the lambda 1 is equals 1, the lambda e minus a is equals to the 0.4 and minus 0.4, the minus 0.3 and the 0.3, and we could times the x1 x2 to the 0, and the x1 x2 is the eigenvector 1 cursive 1 is equals to the 1 1, and when the lambda eigenvector lambda 2 equals 0.3, the lambda e minus a is equal to the the minus 0.3, minus 0.4, minus 0.3, and the minus 0.4. And times the x1 x2 is equals to 0, and the epsilon 2 eigenvector is equals to the x1 x2 is equals to the 4 and minus 3. So we could get the matrix P is equals to the 1 1 4 minus 3, and the inverse P, we want to compute the inverse P, we could use the P and the E vector and to transmit it into the E and the inverse P matrix. So the inverse P by the transmit compute the row and the column of the matrix P and E to transfer it to the E and the matrix P inverse, and so the matrix P inverse is equals to the 3/7 and the 4/7, the 1/7 and the minus 1/7. So we could put the inverse P matrix times A times inverse P is equals to the diagonalization matrix is equals to the lambda 1 lambda 2 is equals to 1 0.3. So the matrix A, we could write it as the P diagonalized matrix, the P inverse, and for the A over the to the power of n, we could compute it as the P the diagonalized matrix to the power of n and the P inverse matrix. So it is equals to the we compute above is that the p is 114 minus 3 and the diagonalization vector matrix is 0.3 to the power of n, and to the times the p inverse matrix, the 3/7, 4/7, 1/7, and minus 1/7. So we could compute the limit when n to the infinite, the point probability of xn equals 0, and the limit n to the infinite, the probability of xn equals 1. The matrix is the probability of x1 equals 0 and the probability of x1 equals 1. The matrix times the a to the power of n, so it's equals to limit n to the infinite, so it's equals to that the limit n to the infinite, the 0.2 and 0.8 times the 114 minus 3, the 1 to the power of n, 0.3 power of n, and this matrix, inverse matrix, and to compute this, because n is infinite, so the 0.3 to the power of n is equal to 0. So we could compute this, and the result is 0.3 and 2 is 3/7 and the 4/7. So the limit n to the infinite, the power of the probability of xn equals 0 is equals to the 3/7.